What's up, guys? Welcome back to Vanover Machine and Repair, and welcome back to the beautiful Lion Lathe project. Now, if you've been following along, we've been doing modifications to this brand new machine to bring it up to the level that I like to have my machines at and make it last longer and more enjoyable to use. Today's modifications are no different. We're going to be focusing on the tailstock specifically and addressing one major concern that I've had from day one, and we're going to get that fixed in today's video. Taking a closer look at this tailstock, overall I'm very happy with the unit, mainly because of the 2-speed gearbox and the quick lever for locking down the tailstock. Both of these features make this tailstock a dream to use. But since day one, it has suffered from one major problem, and that is that this tailstock is very difficult for me to move. Now, I am 135 pounds soaking wet, so that's a contributor considering this tailstock's probably about 500 pounds. But the tailstocks on machines smaller than this are a little bit lighter, and the next step up that Lion offers has a hand wheel that interfaces with the rack, and this machine falls in between those two, and it's kind of the redhead stepchild that doesn't get the hand wheel, and so for me it's hard to operate. So we're going to be adding airlift to this tailstock, which is hopefully going to allow it to slide nice and easy, and airlift has other benefits which we'll discuss in a minute. But first, what I want to show you is how much effort it actually takes to move this. So we're going to set up a scale in the back, and I'm going to show you pushing effort as well as pulling effort, and you can get an idea of about how much effort it takes to slide this thing. In the name of science, we have rigged up a scale to the back of the tailstock. We are going to be using that to push on the back of the tailstock, and we'll record our reading. Now, in all fairness, this machine has not been cleaned and oiled in 2 weeks. There is a film of oil on the ways, but I want to give you a baseline in reality. Not always do you have the opportunity to go and operate the tailstock under an optimal condition. Once we have that baseline, I'm going to go ahead and get the ways cleaned up and re-oiled, and we'll repeat the test. I assume those numbers are going to be a little bit lower, but I would like both as a comparison. And then once we do the airlift, we can see how much of an improvement we have from stock. 84 pounds to push that. 84 pounds, pretty consistent. One more. That one was about 85, it didn't move. Next, we're gonna switch to the machinery weight scale, and I'm gonna pull this and record what our reading is there, and we'll go from there. All right, we're using the machinery scale, and I actually have it set up to the carriage. This should hopefully be a little bit more consistent. We're just gonna go and kind of see what the max is. So right now we're at 0 pounds. So 70, 84, 90, there it is, it moved, so around 90. So according to this, it takes about 90 pounds to operate this tailstock in the current condition. Just to give you a frame of reference, that's only 40 pounds less than what I weigh. We went ahead and oiled the tailstock and oiled the ways. We slid it back and forth and made sure all the lubrication got in there where it should be. Now we're going to take a measurement and see how it compares. So we should be about 0 pounds. Yep, we're pretty much there with no effort. Now I would expect to see about 10 to 20% less effort sitting on a film of oil, but we're going to find out. 70 pounds is a little more surprising than I thought. 91, 92, okay, it moved right there at 92. So this took exactly the same amount of effort as it did before. So in this case, it seems that this tailstock takes about 80 on the low side to 90, 95 on the high side pounds of force to move it. And that's fairly consistent with what we've seen from pushing on the back. Now, I don't know about you, but for me, that's a little bit too much. So now we're going to talk about how we're going to execute the airlift on the tailstock and what the benefits of doing that are. Now, I'm hoping that by doing airlift on this tailstock, we can reduce that 90 pounds of force down to about 1/4 of that effort. Now, typically, tailstocks that are heavy operate with the rack, and that's what we have on the pacemaker, and that's what a lot of large machines have. But I opted to go away from that method for the airlift for a couple reasons. One, this tailstock was originally set up with a tag-along feature, meaning that it can interface with the carriage. So if you're doing deep drilling, you can actually pull the tailstock with the carriage. Now, a couple of you guys have suggested moving the tailstock with the carriage, and that is a good idea, but in reality, if you needed to turn the lathe on every time you wanted to move the tailstock or hook it to the carriage, it just doesn't make sense in all applications. So you do want to be able to move the tailstock independent of the carriage most of the time. But when you have a hand wheel that interfaces with the rack, you give up the ability to use that tag along feature. And in my case, and the deep drilling that I do here and there, I want to retain that feature. Now currently the feature is disabled because of the DRO, but we're going to be adding a new component to make that be a reality again, and I don't want to lose that if we go with the traditional rack mount. The other issue that we run into is when we have a handle on the tailstock, that handle is going to be very close to the motor area over here on the carriage. You just have a lot of things interfacing in this area, and it makes for a crowded area. The airlift is a lot more low profile. The other benefit with the airlift is going to minimize long-term wear on the tailstock. I have another one of these Lion lathes, and the tailstock bottom was worn pretty severely because it had like a 20-30 thou shim in the base. That happens because these tailstocks wear down as a result of the friction from them sliding. The other problem with the Lion lathes is they don't have any oiling or active oiling on this tailstock. The airlift is going to help us mitigate wear because anytime we move it, this is going to be floating on a cushion of air, which minimizes the contact surface, makes it easy to move, which increases the life of the tailstock, and in turn is just going to give us better quality parts for a longer lifespan. So the other thing we're going to do while we're in there is we're going to add a powered oiling system or a SLR, single shot lubrication system. We did add this on the top slide, but since we're going to be drilling holes for airlift, we're going to drill an extra hole on either side for oil, so that way we have a automatic oiling system, so that way in conjunction with the airlift we'll have oil that is dispersed from the center out, which will help mitigate rust that can form from coolant getting trapped like we have there, and it will also make the tailstock slide even easier and last even longer. On the bottom we have a nut over here, it has a cotter pin on it, it's a little hard to see. Slide this out of the way. Here's that bottom piece. It's a nice little clamp thing, cotter pin, our impact, and our bolt. As a point of reference, the tailstock on the pacemaker weighs 450, and the one on our larger Lion lathe is about 600. My guess on this is about 400 to 500. All right, I was wrong, 312, not too bad. So this tailstock is actually lighter than the one on the pacemaker by 100 pounds, 140 technically. We have our bolt that's in the way. We're going to separate the top of the tailstock from the bottom. This is not necessary. We are going to have to redo the alignment of the tailstock once we're done. But this is just going to make doing the modifications of the base a little bit easier because we're going to need to get this in the mill or the radial drill to do our drilling. I'm guessing behind this window we're going to find stuff for the quick engagement. So if you do have to shim a tailstock, typically where you want to do it is in between the base and the top part. You don't want to put any shims on the actual bottom that slides. So this is where our cam is at. I think we can actually leave that in place. So I think all we got to do is remove this nut, and then we can lift up and this will come apart in 2 pieces. I believe all we have to do is lift straight up. It was loose more or less. Go ahead and move this out of the way. We got the tailstock base flipped over, and this is what we're thinking. So this outer sort of teed line here is going to be the airlift in the center. We're going to have a hole here in the middle where the air is going to come up, and we're going to have a milled channel here for the air to come in and create an air curtain. And then on either side, we're going to have 2 lines for oil delivery, and then these lines are going to have a hole in the center, and they will drill down and intersect with some channels. So on this side, we're going to have 3 long holes drilled to the center, and then on the other side, it's going to be the same. We have a long line here and a long line there for the airlift, and then the oil delivery here will be in the center on this flat, so it'll kind of drip down and get on to both of these areas. We're at the radial drill to get these holes drilled. We're going to drill 8 inches deep, and we're going to be using a 1/4 inch drill bit. This is a little long, but this is pretty much all I have for a deep drill bit. We're going to come in here with our spot drill or center drill and get started. Then we'll come down a little bit with a normal 1/4 inch bit, and then we'll finish out. There's several ways to do these holes. In our case, we're just going to drill halfway for all 3 of them, and then we will groove out to bring the oil and air farther to the ends. 11:29. This is where the radial drill really shines. We have a super long drill bit. We have the head all the way up, and we can fit this part just barely. We have that much clearance. Actually, I had to switch out to a shorter body so the drill bit would fit without modifying it, and this would probably not be possible in a mill just due to clearance, but we can do it in the radial drill. I've got my depth marked on the bit, so let's come in here and get these holes drilled. Now that we got all the holes drilled 8 inches deep, I'm going to come back in with an 11/32 drill bit and drill down just like a 1/2 inch, maybe 3/4, so we can get our 1/8 inch MPT tap to tap all 6 of these holes. we're gonna hand tap all of these holes, 1/8 inch, 27 NPT, using the tap follower by hand so we get this straight. All right, that looks pretty good. We got our 6 holes drilled and tapped, and everything turned out pretty good. And most people would stop here, but we are gonna complicate things a little bit more to simplify it and make it a little bit more low profile. So right now, as it sits, if we just installed our 6 push to connect fittings, we'd have 2 over here for air, 2 over here for air, and 2 in total for oil. And we would have kind of a rat's nest of air lines on the back of the tailstock. And sometimes you use the back of the tailstock to press it, and I don't want to impede this area if I don't have to. So in order to get around that, we are going to take and we're going to cross drill 2 holes here and 2 holes at the base, and we're going to run a connector for the oil and a connector for the air to join both of these sides together and simplify it down to 2 fittings on the back side. Not only will that only have 2 ports coming out of the side instead of 6, it will move it to the back so we don't have to see it and we don't have to touch it. We just need to be really careful when we're drilling these holes because we don't have a lot of margin for error. There we go. We're over here at the Bridgeport. We're ready to get these oil grooves and air passages machined. I would really like to use a ball nose end mill, but I just don't have one with a small radius. So we're gonna use a chamfer mill and go ahead and take care of this. We're gonna run at a high RPM because of the tip, and hopefully we don't break the tip. All right, that's the oil groove on this side. All right, that's the oil groove done on this side. I'm gonna choke up on this a little more. All right, we're gonna drill the holes for the air now. All right, we're gonna drill the hole for the oil passage in the back. There's our oil passage. Now we need to come in here and machine our lines for the air on this side. Before we tilt the head, I do want to drill the holes for the air passages because the holes are going to be on an angle. So we need to plunge down and create a flat spot with the end mill on both sides, and then we'll drill a hole. All right, we got this head angled 45 degrees. Let's see what she's got. We got all the holes drilled and the slots done in the mill, and off camera I went ahead and took an opportunity to drill additional holes in the base of the tailstock for future mounting of additional accessories. In total, we put about 25 holes additional into this tailstock base, which seems like a lot, and it is, but hopefully in the future as we add different brackets and features, all of the holes will be there and it should be pretty easy and we don't have to break it down like we do right now. The next step is to take some of these NPT plugs and come around here and plug some of the ends that we don't need. And then once that's done, we're going to use compression fittings on the inside to connect both sides. We are going to be using the Yorlock fittings in addition to copper lines. I want to go with copper on the inside because I don't want to service this. If a push to connect fails on the inside, we have to take it out, but a copper line should be good for many years to come with no issues. So let's go ahead and get some thread sealant on this and get all these plugs and compression fittings installed. Went ahead and made sure all these channels were nice and clean so we don't have any debris in there. And I'm using the ones that have sealant pre-installed. If we ever need to clean these channels out, all we have to do is remove these plugs and we're good to go. We're going to go ahead and repeat this in all the other areas that need to be plugged. Got the air lines in, and this is how it kind of finished out. We had to do a U-bend here so that I could get it in one side and kind of flex the other side into place. And we went ahead and water tested everything and made sure it seals good. So now all the channels on this side are connected to all the channels on this side, and they're all accessible via 2 ports on the side, which I've temporarily plugged. So all the work on the tailstock is complete. The tailstock is ready to go back together, and all the rest of the work we're gonna do is valving and air lines and stuff like that that we can do outside of modifications on this unit. Well, we got some bad news. So I got this back together. We do have a job I need to use the tailstock and the lathe for. So I quickly reassembled everything, and I just out of curiosity wanted to test the work that we have done to see how well it will work. Now the airlift does work, but it is pretty loud because it's leaking a lot of air. So against my better judgment, I decided to do a blue up, and lo and behold, you can kind of see the contact area is terrible. I'm not even upset. This is exactly how it was on the top slide, and we haven't even pulled the apron off. I wouldn't be surprised if the apron looks like this too. The fit up on this machine is really where they cut corners. That's the most labor intensive part, and that's also the most critical part in terms of the accuracy and, most importantly, longevity. And in this case, you can see we're touching on the ends and down here, and ultimately where our air delivery is, there's no contact. So it's no wonder why we don't have a seal there, because it's not touching there. So we need to revisit this at a later date. We're gonna have Daniel come in here and scrape this out. So what are you thinking, Daniel, now that you've seen this?
Well, I'm thinking that I'm not seeing a lot of blue. We just took a rub on the bed, and well, I should say, I already took a pass on this, so I got one small cut on it, because before we were just getting contact on all 4 corners visually with the blue. But if you put an indicator on the top, one of these corners wasn't even touching. So you're getting a false read, probably just from it coming down onto the bed. So I'm not seeing a lot of blue, not a good contact, so it makes sense that Kyle's airlift was just hissing out. There's no resistance, so of course the airlift is not gonna work. So right now, we're trying to just get some more contact on the flat and on the V. I don't think it's horrible, but based on the 2 rubs that we just took, this was clearly not fitted to the bed. So we're just gonna fit it to the bed.
How much contact would you say there is in there?
10%.
And how much percentage would you wanna see?
I mean, 75 to 80%
okay.
of coverage. You know, like if it were fitted, you would have 2 pads, like 3 or 4 inches long, that was making contact, and this middle section would be relieved. So this was open, so you'd have 4 pads on the outside. And the middle is just relieved so that it doesn't rock over time, because as you pull this one direction, the front of it is gonna wear more because it's heavier on the front, and vice versa. If you pull it backwards, it's still heavier on the front, so it's gonna wanna drag this way and it's gonna wanna drag that way. If it were high in the middle, the thing would want to rock like a rocking horse, which is not ideal. So we cut the middle out a little bit and have contact on the ends. So we're going to try to work our way up to that.
We'll kind of show you what we have so far here in terms of contact. So we got a little bit here and a little bit here. There's a little bit of a glare, and then on the other side, you know, we have a little bit here, and then we have a little bit over there as well. So you're just cutting the ends down first in general? You're not going after the blue spots?
No, I'm just generally kind of scraping the whole outside.
You can hear it rock.
Yeah, so I know one of those flats isn't touching on the V. Looks like we've got a little bit of bearing up to about here. Little bit of bearing, well, consistent bearing up to here. Looks like it's dragging a little bit, got a couple little spots. I'm not really gonna count any of this. It's really just here. We have one good spot there and a line over here, and this is the open side that I was talking about on the V. So I'm calling this a false reading because it looks like just smudged from coming down. So yeah, we're hitting here, hitting here, and hitting on this side.
Cool. You know what, I feel like when I was doing some heavy machining, this tailstock slid because I had an indicator. Do you think when it's more scraped in, it's gonna be less likely to slide when clamped down, or not necessarily?
I mean, I'm sure it'll help a little bit having good contact, but I feel like on those clamps on the bottom, you know, there's not a lot of contact.
Right.
That it pulls up to the bed. If there's oil on it, a little bit of grease or something, those things do move around.
Yeah, I'm more...
Especially if that cam isn't adjusted where it like really locks in. Yeah, I think once we get this all set up, we can see how the airlift works and see how that cam, we can adjust it to fit a little better.
Yeah, because that, yeah.
And just take some heavy cuts and be like, okay, maybe we got to add a little bit of support here.
All right, Daniel's been working here for about 4 hours. I've been doing my own thing, and I've just been letting him jam out on getting this scraped in. And at this point, we may scrape it a little bit more, but we're gonna stop here and test the airlift, see if it's gonna work. And then if it is, we may call this good enough. And if it isn't, then we may try to scrape it in, pick it in a little bit more.
We're at a point where we're getting good bearing all over on the flat. And we're getting pretty good bearing on one side of this V and decent bearing on this other side. We can see it's hitting all the way across the V on both sides. You can see the bearing's a little light in this corner, bearing's a little light under here. So we could pick this side in and bring everything in a little bit tighter, but you know, because we're sort of like making up this airlift with this tailstock, it's sort of an unknown whether or not it's going to work really well. We just want to figure out if it's really worth our time.
Feels nice.
Feels good.
I can feel it from here. Feels better than it did when we started, I can tell you that. Moment of truth, guys.
It's definitely working. I think this side of the V
is leaking, right?
Just on the outside. There's nothing coming out on the flat.
Wow, that is beautiful. Look at that, guys.
And I think it might help with the top on it.
Yeah, more downward.
Keep it weighted. Your gauge doesn't even go down to 0. It starts at 20. That's maybe 3 compared to, oh yeah. So that's 3 pounds. You still can push it with 2 fingers. That's close to 10. Yeah. That's pretty cool. I'm curious what the actual lift is, so I'm gonna get an indicator.
Okay.
And we'll see. We'll zero it out and then see how much it actually lifts up. So ideally you'd have 4 indicators on all 4 corners at the same time as it lifts up. All right, so I got it set on a block here at 0. See if we can turn it up to 5 pounds on all of them. That's maybe 2.5, 3/10 of lift. It's kind of jumping around a little bit. Let's call that 3/10. Let's try to get it at 5, so at least we have a good reading to go off of. So that's about, you know, 10 pounds of pressure, and we're getting a half thou lift. And we'll check the other side. So we'll get it up to a half thou lift. Yeah, that's 10 pounds of pressure.
That side isn't lifting much, right?
It's not lifting really at all.
Yeah. You started to leak on this side.
Maybe 2/10.
All right, so Daniel's been working here for a little bit. Try not to distract him. I haven't shown you guys a ton of the scraping. A lot of this stuff is pretty redundant. So Daniel, bring us up to speed on where we're at with the bottom here.
Okay, so we have the flat and the V scraped in, and we wanted to get a little bit of twist out. This was kind of sitting at a weird twist like this, and we wanted to flatten everything out. And I wasn't too concerned with measuring the parallelism of the top, like indicating the top, because it was already way out. So I was like, you know, we're just gonna ignore this surface completely and just make sure we have bearing all over the bottom. You could keep scraping this and we could get it even closer. And for what this is, I really don't think it's worth it. And we've spent probably 8 hours or so scraping this in. Because it's a tailstock and you're gonna clamp the heck out of it, I don't think it's worth chasing our tail for another 3-4 hours getting it absolutely perfect. So we know it's flat, we know it's got bearing all over, it's not rocking, it's not twisted. So we're happy with that. And as we were scraping this in, we noticed that some of the slots that were machined in here for the air, this side particularly, the V on the bed doesn't actually extend this entire width. Like this V measures 5/8 roughly, but the V on the bed doesn't. It actually comes to where this blue line is, which is about a 1/2 inch. Now, a 1/2 inch is just inside of that slot. This guy's poking out of the actual surface of the V. So what that means is when the air is on, air is just gonna start hissing out of this spot right here. So what we're gonna do is just fill this in with a little bit of glue just to plug it. Keep it from escaping out of this one little corner. Everything else should be okay. It's a little close to the edge, but it should be contained on the bed to create that like resistance to actually lift this up. And there's no real good way of knowing that until you see the actual blue on here. And because this side in particular, there was absolutely no bearing on until we got to a point where it was scraped in. We're like, oh, that makes sense why it was hissing out, because that slot was actually sticking out from the outside of the V on that side of the bed. Now that we have good contact all over, we'll fill that in. We're gonna put the air back on it and see if this changes our lift at all. And then at that point, we'll throw the top of the tailstock on and start measuring the alignment of the quill and see where we're at. We're just gonna plug up Kyle's mistake and pretend it never happened.
Honestly, I'm kind of glad that it's only just that one part. I would have thought I'd be filling all these grooves up. Got the tailstock base back on the machine, and Daniel's just getting ready to test our air and see if it's gonna leak like crazy or if it's gonna work great.
Yeah. Can't tell where it's coming out of. That's 10 pounds. I'm curious with the indicator. See, because last time
The one side wasn't lifting at all.
Yeah, one side wasn't lifting at all. So I'm curious if at least it'll lift up the same.
Yeah. I'll get the soapy water. I'm kind of curious where it's leaking. All right, so let's bring you guys up to speed on the airlift. Now in the last frame, you saw us getting it over on the machine and trying the airlift out for the first time since Daniel was here, and it didn't work too well. And the reason for that is the passages that we had machined in here, that I had machined in here, were basically leaking. And I did not show what I did here on the tailstock, which we're going to talk about, because it was a lot of back and forth. But basically what I did after that is I added some additional slots and holes to test which combination of holes and slots would be the best in terms of the most efficient airlift, but also not a ton of leaking. So here's what I learned, and I think, you know, will throw myself under the bus for hacking up the bottom of my tailstock, so that way you guys can learn in case you guys want to do this. So originally I started out with some slots and no holes. So I had some air delivery to the center of these slots, and what I learned by doing that is that was very efficient in terms of air flow. So we needed a low amount of pressure to achieve the lift that we needed. However, since the slots were long, it gave a lot of opportunity for leakage. So it was very loud, but it worked very well. So if you're trying to do something and you don't have a lot of air pressure, that may be an option for you, but it's gonna hiss quite a bit. And in our case, it did. And I'm OCD and I didn't like that hissing. So I messed around to kind of get the least amount of hissing, but it came at a cost, which we'll discuss in a minute. After I did the long slots and realized we had too much leakage, we went and I machined some smaller slots on the ends, and I actually capped off my original slots, and that was gonna be a compromise. It was gonna give me some lift, but it was gonna decrease the surface area of the slots and hopefully mitigate some of the leakage. And it did do that, but it was still loud even still, much louder than I wanted. And so I went and did a final iteration where I drilled holes on the end and I capped off the small slots and the big slots and went originally back to just the holes. And the holes worked very well, and that's where we settled on. The con with the holes is you need to run a much higher pressure, and in a way it is less efficient. So at this current moment we're running on the holes, and the holes need to be running at about 80 psi to create enough lift, and the lift isn't as aggressive, meaning it takes a little bit extra force to move this. However, it's much quieter. So it does work. It does cut the effort from about 90 pounds down to about 20, which I think is acceptable, but the actual air leakage is much lower because the contact area is much smaller, and therefore the opportunities for leaks is less. So I wanted to just kind of give a breakdown of that learning process because there's not a lot of information out there on this. And in this case, the other thing that we learned is the V-ways behave differently than the flats. So in this case, we actually have 4 holes applying air to the V-ways, but only 2 holes because the V-ways, because they're on an angle and because more weight is over this area, it works out to where we want more air pressure coming out on the V-ways to keep everything nice and level. And that's the other takeaway if you're gonna do this, is either you really should run 2 separate regulators to get different pressure on either side, or you have to experiment with the length of the slots, which will help balance out the pressure so you can get the correct amount of lift with the tailstock fully assembled, because like in our case, the weight is not completely centerline, and even if it was, the V-ways are gonna behave differently than the flat. So that's where we are here. We're gonna get it flipped back over and then move on to bluing up the top surface, and we can see how that kind of fits with the top of the tailstock.
All right, so we have the bottom of the tailstock sitting here, and it's separated from the top of the tailstock. And as you can see, we blued it up because I'm curious to see how flat this surface is as it will match up to the top of the tailstock. Because we got the bottom all scraped in, it's looking really good, it's got good bearing, and now we're building from the ground up. So we checked this off of a surface plate, and you can see bearing in the corners. You can see a couple high points here and there, but it doesn't look great, but it's showing me that it's relatively flat. We know that it's not twisted, it's not messed up. It was scraped at one point, you can see the original scraping. So I'm not super worried about this surface, and the reason I'm not worried about scraping this surface in is because we already checked the alignment of the quill to the center line of the spindle. And in order to check the center of the quill to the center of the spindle, use a coaxial indicator, which is currently mounted in the chuck still. And that allows you to, the center line of the spindle as it turns and the center line of the quill, you can sweep that center point and see how far it is how far out it is side to side and how far out it is up and down. Once we dialed it in, the center line of that quill is a 0.5 low relative to the spindle. So, which makes sense because we scraped about 1/1000 of material away from the bottom. So we dropped the whole thing 1,000, and the reason why I'm not worried about this surface is because we need to shim it back up, and because this surface and the bottom of the tailstock are not wear surfaces, we're just gonna slide either a 0.5 shim or a 1,000 shim right between these two. Typically when you see a machine that's new, the quill on the tailstock will actually be a little bit plus. Like when we checked this, it was about 1,500 plus, or higher than the spindle. And that's because the front of the tailstock will wear faster, because as you drag it, the nose of it, you know, it's heavier on the front. So the front of it's gonna wear, so it'll actually kind of sit like this over time. So they keep the whole thing a little bit high, so as it wears in, it'll wear in to be 0, 0, or center to the spindle, and give you a little bit more longevity with the center line of the quill relative to the spindle. All right, so we have the tailstock slid up to the chuck here, and we have a coaxial indicator in the spindle, and we're sweeping the inside of this bore. And so you can see the run out on the needle is about 2/10, and that's mostly coming from the side to side. So if we have the needle sitting on the side of the inside of the bore, it's like maybe 2/10
combined.
Yeah, 2/10 off on that side. And if we bring it around to the other side, that's 0. So we're out 2/10 side to side, which is totally fine. On the top, we're at 0. And on the bottom, we're about 1,500 plus. So that the bottom of the quill is 1,500 high, which is good. Sweeping center to center, from the center of the spindle to the center of the quill. And we didn't really have to mess with the shim that much. We just have a 1,000 between the top of the tailstock and the bottom. And you see we just had it taped down, just so when we came down with the tailstock, it didn't get all crumply, because this stuff is so thin. It's really easy to get bunched up. So we just taped it down so it was a nice clean surface, nice and flat. And then set that on it and bolted it down.
Got the tailstock back together, and we're just gonna give you a demo of the airlift. And overall, I think this worked out really, really well. Now, keep in mind, I am gonna be setting up a limit switch with the handle. So what's gonna happen is when the tailstock is unlocked, the air will come on, and then when it's locked, it's gonna turn off. And that's gonna work out really, really nice. We're also gonna have that limit switch / solenoid set up with the machine. So when the machine is off, like it is now, and the spindle is off, the actual air won't even come to the machine. So 80% of the life of the machine, there's gonna be no air, no leakage. When we come, we turn on the machine, it activates the solenoid, bringing air over, allowing this to be assisted. And then when we lock it, it turns off the air. We have a little old regulator, and we're gonna run about 100 PSI. And before we were about 90 PSI, 80, 90 PSI to operate this. And now, you know, there is some effort. I measured it, it was about 20 pounds, 25 pounds. But as you can see, you know, this thing has a nice assisted movement. Now, again, it's not gonna be 100% like floating on a cloud. I had it where it was, you know, 2 fingers and you could tap it and it would just glide, but it was leaking quite a bit more. I don't know if you can hear it. There is a little bit of air leakage, but it's not that loud. And I think this is gonna work out really, really well.
All right, so we got Kyle's tailstock all finished up, and I think it's pretty cool. I've personally never seen an air assist tailstock, which I don't know if it's like a new phenomena or if it's something that exists that I'm just not familiar with. But I think it's a really nice feature. And I've seen them where they have rack and pinion that you can move it by hand. And I think this is pretty sweet, you know, like this thing weighs 415 pounds, and it doesn't take much force to move it. And it's scraped in, and the center height's pretty good. So with an air assist, I mean, it's really nice making improvements to your equipment, and Kyle does a pretty good job at it. I'm happy with how it turned out. I think he's pretty happy with how it turned out. Maybe, you know, 8 hours of scraping between, you know, taking things apart and assessing and checking alignment and stuff. So really not too bad as far as the work. I think Kyle did the most of the like head scratching. You know, I was just here for moral support as he was figuring out like the engineering, like how many holes and where to place them and should there be slots and what sort of pressure, you know. That's just trial and error. And I think just jumping into it and figuring out it as you go. With a brand new machine too, you know, the stakes are pretty high for Kyle to get into it like that. And I think in a couple days, like being able to bang it out and have something that works a lot better than when it came from the factory is great. So kudos to him, and I'm a little jealous myself, so we'll see. Maybe we'll add some other air assist to some of these other things in here.
Or maybe Danny's lathe will get it next. All right, well, we'll see you guys on the next video and continue on with our scraping.